In the previous lecture, we discussed the useCallback hook, which focused on performance optimization. So, in this lecture, we are going to discuss the useMemo hooks, which also focus on performance optimization. The React useMemo hook returns a memoized value. And I want you to think of memoization as catching a value so that it does not need to be recalculated. Take note, the useMemo hook only runs when one of its dependencies updates. And that improves performance. So, to understand how it works, we are going to exemplify it. Let's quickly create a new package called useMemo practice. Right within the components, new folder. Within the useMemo practice, let's create a new component. My memo counter .js. Quickly generate the functional component, and then let's declare the necessary state variables and its setter function to be used. And for sure, you have to import the useState hook. And I'm going to do counter A. So what I just have to do here is to use the karma case, which is for the setter function. And the initial state is going to be 0. Highlight, duplicate it. And then I'm going to highlight the big letter A, Command D to select the occurrences. Wipe it off, change it to B. So we have the counter A and counter B state variables. It's as simple as that. And over here, we are going to define a function to increment counter A by 1 and then also increment counter B by 2. Const increment A equal, set it to arrow function, and then I'm going to do set counter A in brackets. We are going to take in the new update, counter A plus 1. It's as simple as that. Highlight, duplicate it. Just have to select the occurrences of A like this, change it to B. And over here, we just have to do counter B plus 1. So we want to exemplify the useMemo with a simple counter application. Let's quickly have something rendered on the screen. Here we're going to have a p tag. Within the p tag, I'm going to do counter A is, of course you should know these by now. And here we want to implement a button to increment counter A. On click of this button, we are going to call the function increment A. That's simple as that. So what I'm going to do right now, I'm going to have another div, highlight this guy from lines 18 to 19, move it into this new div that we created. So let me quickly format the code. Perfect. So I'm going to highlight from lines 15 to 18, duplicate. Here we are going to do B, B, and B, and B. Oh my God, I should have just selected the occurrences and do it once. When you save the application, head on to the app.js and let's have it rendered. This place is quite messy, but we have to manage it like that. Import my memo counter from, you already know. Come down, highlight, place a comment on it. Check it out on the browser. Beautiful. Everything is working perfectly fine. So let's try it on A. Good. B. Good. Everything working perfectly fine. So here exactly is where the fun begins. Now let's improve the application. So let's say we want to display even when the number is even, and then odd when the number is odd. Let's quickly improve it. Come here. We are going to have another function. Const even number. Set it to our function. So this guy is going to take in results. And over here, I'm going to do result equal counter A modulus 2 equals 0. That's simple as that. And then we have to return whatever the result is. Perfect. Having done this, let's quickly display it on the UI. So right within the p tag of counter A, we have to place some condition over here. So counter A is whatever the state value is, and then if it is even or odd. So we have to specify if the number is odd or even. And I'm going to do it is. So here, first we have to call the function even. And after that, we have to put a check on it. If the number is even, then we are going to say even. And else, we're going to say odd. That's simple as that. Save the application and check it out on the browser. Reload. Okay, so let's increment A. Can you see? It says counter is 1 and it is odd. Increment again, it says counter A is 2 and it is even. Just like that. Alright. One more thing we want to do that is extremely important is that we are going to try to induce slowness into the function. So let's assume we want this function to be executed within some few seconds. Alright, so we want some delay in execution. So for that, we have to induce some slowness into the function. Let's quickly do that. Head on to VS Code, and right here, I'm going to do let I equal 0. And then, while I is less than, we are going to have 0 9 times. Exactly. And then, we have to increment I by 1. Having done this, we have induced slowness into this function. So this will slow down the calculation in 2 seconds. Head on to the browser. Let's reload. Now when I click on counter A, can you see? It takes some few seconds for counter A to get incremented. Try it again. Do you see? So here exactly is where the issue lies. So the slowness was induced on counter A. But now when I click on counter B, do you see? We still experience the same slowness. Let me try it again. Do you see that? It takes some few seconds for counter B to get calculated and have the result displayed on the screen. But look, that is not what we want here. All we want is to induce slowness on counter A and not on counter B. So we don't want this to affect counter B. So what happens over here is that whenever the state gets updated, the component will re-render. And when the component re-renders, the function even number is invoked for the second time. And for sure, the function is very slow. And hence, it will slow down the whole process and UI update. We don't want that to happen to the application. So the solution to this problem is to prevent unnecessary value from being recalculated. And in this case, we are going to inform React not to perform this computation when we are changing the value of counter B. It's as simple as that. So there is no need to calculate and show whether number is odd or even when dealing with counter B. Because that exactly is what the application seems to be doing right now. Go back. When you click on counter A, it takes some few seconds to calculate and show if the number is even or odd. Counter B is not interested to see if the number is odd or even. But still, when you increment counter B, it takes some few seconds to get calculated, simply because the slowness we induced on this guy over here is affecting this guy. And therefore, we have to prevent unnecessary calculations. And to prevent this unnecessary calculation, we have to make use of the useMemo. Go back to VS Code. So to implement the useMemo hook, first, it has to be imported, just like other hooks as well. The useMemo hook is a function. We have to invoke it. So come right here. I'm going to do useMemo. The useMemo will take in the return function, which value needs to be couched as its first argument. And in this case, the function to calculate either the number is even or odd. So here I'm just going to copy from here like this, highlight, cut, come here, and paste it as the useMemo first argument. So the second argument is a dependency array, comma, taking an empty array. And for this function to get fire up, it has to depend on counter A. And I'm going to do counter A, just like this. And after that, highlight this guy, cut, come here, assign it like this. So having done this, the even number is no longer a function call because it now stores a value. So go back to the UI and remove the parentheses. We have to remove this guy. Save the application and check out the browser. Reload. Alright, let's give it a try by clicking the increment A. Can you see? It takes some few seconds for counter A to get incremented. Take a look. So let's try it on B. Do you see? Counter B gets incremented without wasting any time. Now, the slowness we induced on counter A is working perfectly fine only on counter A. And this time around, it doesn't affect counter B, simply because we have implemented the useMemo hook to optimize the application. And in this case, we are having the slowness being induced on the appropriate counter. So, whenever counter A changes, React will recompute the value and disregard the card value, which simply implies it is not going to use the card value anymore. So since the value never changed for counter A, there is no need to recompute the odd or even value. And then React will use the card value from the previous render. So hence counter B will not be affected by the slowness that we induced. And now the question is, what is the difference between the useCallback and the useMemo? useCallback is used to catch a function, whereas the useMemo is used to catch the result of an invoked function. It's as simple as that. Or you can say that the useCallback is used to catch a callback function. This is all for now, and see you in the next lecture.